Hello students, today we are going to study chapter 4, Structure of the Atom in Chemistry. Atoms and molecules are building blocks of elements and compounds. Why do atoms of one element differ from each other? What is the inside the atom? Can there be smaller particles than atoms? All these questions we are going to discuss in this chapter. So let us look into the slides. Charged particles in matter. Atoms have three types of subatomic particles. They are electrons, protons, and neutrons. Electrons are negatively charged, protons are positively charged, and neutrons have no charge. Discovery of in 1900, J.J. Thomson discovered the presence in the atom. In 1886, E. Goldstein discovered new radiations in gas discharge tube and called them canal rays. In 1932, Chadwick discovered the presence of particles having no charge in the atom called neutrons. Subatomic particles of an atom are electrons, neutrons, and protons. This slide shows the carbon atom subatomic particles of a carbon atom. 6 protons and 6 neutrons are there in a carbon atom. Now, what are the constituents of an atom? Electron, neutron, proton, and nucleus. These are the constituents of an atom. Dalton's theory of atom was proved wrong by discovery of electrons and protons, which are smaller than atoms. Now we will discuss how the electrons and protons are arranged in the atoms. Sir J.J. Thomson first proposed the model of structure of atom. So let us look into this slide. Plum pudding model or blueberry muffin model. It was proposed in 1904. Negatively charged electrons are surrounded by a positively charged pudding. Thomson proposed that an atom consists of a positively charged sphere and the electrons are embedded in it. The negative and positive charges are equal in magnitude, so the atom as a whole is electrically neutral. We can also think of a watermelon. The positive charge in the atom is spread all over like the red edible part of the watermelon, while the electrons are studded in the positively charged sphere like the seeds in the watermelon. Although Thomson's model explained that atoms are electrically neutral, the results of experiments carried out by other scientists could not be explained by this model, as there were some drawbacks of this model. So let us look into the drawbacks of Thomson's atomic model. Thomson's atomic model failed to explain how the positive charge holds on the electrons inside the atom. It also failed to explain an atom's stability. In 1911, Ernest Rutherford, a former student of J.J. Thomson, proved Thomson's plum pudding structure to be incorrect. Then came Rutherford with his model. So let us look into the Rutherford model of the atom. Observations and conclusions of Rutherford's alpha scattering experiment we are going to study after the experiment. Apparatus given by Rutherford: gold foil, lead block shield, zinc sulfide screen, source of alpha particles. Rutherford's scattering experiment. Ernest Rutherford was interested in knowing how the electrons are arranged within an atom. Rutherford designed an experiment for this. In this experiment, fast-moving alpha particles were made to fall on a thin gold foil. He selected a gold foil because he wanted as thin a layer as possible. Alpha particles are doubly charged helium ions. Since they have a mass of 4U, the fast-moving alpha particles have a considerable amount of energy. This slide shows the observations of scattering experiment, where we can see the scattered particles and most particles are undeflected. Observations of Rutherford's alpha scattering experiment. The observations made by Rutherford led him to conclude that a major fraction of the alpha particles bombarded towards the gold sheet passed through it without any deflection, and hence most of the space in an atom is empty. This slide shows the scattering of alpha particles by a gold foil. The alpha particle scattering experiment gave totally unexpected results. The following observations were made. Most of the fast moving alpha particles passed straight through the gold foil. Some of the alpha particles were deflected by the foil in small angles. Surprisingly, 1 out of every 12,000 particles appeared to rebound. Let us look into the observations. Most of the particles were gold foil. Several particles were deflected straight back towards the source. A few particles were deflected at large angles. Based on the observation, there were some conclusions made by Rutherford, which we are going to continue in our next class. Thank you.